Thank you for joining us on this episode of Mac Panel Test Connect, where not only do we connect you with high-performance test connectors, but partners that will help you dominate any testing application. On this episode, the word is modularity, and today to help me speak about modularity, I have Jim Campbell with Viewpoint and Hayden Nielsen with National Instruments, or NI. Jim, would you mind going ahead and introducing yourself and tell us a little bit about you?
Sure, thanks, Matt.
Yeah, sure.
Yeah, so I have been working with Viewpoint Systems, an integrator that has been with National Instruments for 26 years now, and we do design and build of custom test systems for all sorts of test applications. And more importantly, here today, I'm going to be interested in talking with Hayden because we've been working on some pretty interesting stuff around the electro-optics imaging systems test.
Awesome stuff. Hayden?
Hey,
what about
well,
you?
I appreciate the invite. It's great, great to be here.
Of course, yeah.
You know, we're actually in person, which is very odd, you know.
After 2 years, now we're 3D.
This is my first time meeting both Jim and Matt in
person.
In person, right?
Yeah, I was like, I figured y'all were just 2D images on the computer, so it's very good to see y'all are actually humans. That's nice. I thought y'all were program things.
Avatars?
Yeah,
that were just avatars.
Yeah, so no, I appreciate the intro and the invite. I'm Hayden Nelson, to the audience. I work at NI. You know, we went through a major company change. You know, National Instruments is what we're all known as.
Right.
But we've decided that we're more than just national, and we sell more than just instruments. So we can compress that to NI, and I manage our solutions for electro-optic and infrared tests, which is how Jim and I have been working together over the past few years to come out with some great partnerships on some test solutions that help that technology, which is just like going through kind of a major technology change.
So Hayden, as the National Instruments or the modularity expert, right, the PXI expert, can you tell us a little bit about modularity and how it kind of plays into test systems?
Sure. I mean, NI's been in the modular test game for a long time. We were kind of one of the organizations that really pushed down that down that avenue, and we're heavy pusher influencers, I guess,
right,
of the PXI standard,
okay,
which you're familiar with, and and it's an open standard, so we're probably have the most capability in that space, but there's a lot of people that play in there, and it's a nice ecosystem. But the reason we pushed down that is because we saw the benefit and the advantage of going with modular test systems, just because technology is systems today. You look at embedded systems that are out there going into military vehicles, they're kind of going the same direction. They're going into card form factor modular architectures, and having a test system that kind of mirrors that you can match up your I/O and build a test system that's highly optimized for your specific integrated subsystem has a lot of advantages, I guess.
So Jim, as an integrator, can you tell us what the benefits are of a modular platform?
Sure. There's huge benefits. So obviously, as an integrator in the test world, we get involved with a lot of different customers, and each customer's got specific solutions or specific problems they need to be solved. However, from a business perspective, modularity helps both Viewpoint as well as our customers in the fact that we can design systems that we can at least come up with an 80% solution internally and deliver that to our customer and reuse that for the next customer. And furthermore, for our customers, they like modularity because of the fact that maybe their product that we're testing today, call it product A, has got a flavor that's slightly different, but it's got a lot of similarities, called product B. But we're not designing test system for B yet, but there's so many commonalities that you can take A and make some tweaks and turn it into a test for B.
Okay.
Probably a lot of benefit and incremental cost there, because if you're custom building for A and B, if I just need to, it's 10%, from just a business dollar amount, right? Hey, I can upgrade my tester. Now I can do A and B on the same tester. Maybe you're not running full utilization, so it gives you these kind of benefits of I guess test. I think of it in terms of the manufacturing. There's kind of like validation in manufacturing, but being able to use that reuse that equipment. And standardize on it allows you to save a lot of costs. I mean, maybe that translates into a faster time to market, better, better you can pass some of that cost savings on to your customer and be more competitive in the market. Maybe it increases your margins and you're able to reinvest to build more technology for the industry.
You know, it's interesting. I mean, NI came out on the PC platform initially, ISA buses way back when. But
high-tech stuff, man.
High-tech. It was back then. But the whole concept there was to come up with some tools. I think I've heard NI called the Home Depot of the test world. But come up with some hardware and software tools that can be mixed and matched, right? Obviously, when you're going after a specific type of test system, there's specific pieces of hardware in there. But if you think about what else can I do with this, you can start thinking about, well, I'm going to add some analog I/O and some digital I/O, which is pretty generic. But if I put, like with Mac panels, connectors on the front, for example, I can then turn that into a personality that I can bring different wires into the different analog and digital I/O to be able to test different things. And that's a huge cost savings because you don't have to redesign the wheel every time.
Right. Yeah, I was out at one. I can't say which customer, but I was out at a customer site. I don't know, probably about a month ago, and they were doing exactly what you're talking about, where it was a interchangeable, front panel. I'm not sure. It might have been y'all's connector panel.
Right. Test adapter.
Yeah, test adapter. They so they had a PXI chassis behind there, and for one DUT they were testing, they probably used 80% of the instruments. So there's kind of a little bit of an overhead to modularity, but the benefit of it, in that for any one thing, you may not use every instrument or every connector or every for that specific DUT, but they had this test system where it was actually an EOIR system where they had about 5 generations of cameras they were testing, and they could just reuse the exact same tester but then they had the ITA.
That's right.
And we're able to, that thing in and of itself was an engineering project.
Right.
And so, and just being able to rapidly swap these things out, because they don't run, they maybe produce, 500 of these a year. They're really high-end cameras, so they're not testing all the time. But being able to swap them out and not have to redesign the wheel, I've seen
every
that in
single
action.
time. Right.
It was a huge benefit to them.
Yeah. So it sounds like cost is a major factor when folks are firstly just engineering a test system, right? And that's one thing that we hear often is how much it's costing. One thing that from a Mac panel perspective is we really try to drive home the total cost of test, right? It's not just like your initial capital investment, but it's also that long-term investment that is it your maintenance cost, right? Your opportunity cost if it goes down, and you have to maintain it. How many units are you not going to test that day because you have to, maintain it? And it sounds like, a modular approach or a PXI approach kind of helps solve all of those issues.
Absolutely,
is that right?
Yeah.
What are some of the other issues that you guys are seeing outside of cost, right? With, people...
Floor space.
Floor space?
Yeah.
Okay.
Yeah.
And so explain to me what that...
Instead of having a 19-inch rack of equipment for testing that product A and another one for product B with some ITAs in the middle, maybe a Mac panel, you can have one 19-inch rack that tests both.
Right.
You have throughput issues potentially, but if you have that good problem where you have too many products that you need to push out the door, you can make 2 systems.
Yeah, that's right.
But if you don't, then you can actually save a lot of floor space.
So real estate.
Which, cost per square foot, maintenance costs.
That's true.
Heating, cooling,
So instead of maintaining 10 racks, right, you're only maintaining the 1.
The floor space for, and that too, there's the maintenance of the actual test equipment itself.
I had some other thoughts on some of the benefits of modularity. One other than cost, right?
Right.
Is matching the ideal I/O set in an integrated platform, because it's, I like messing with hardware. I love building out these systems and seeing customers with these, customizing it, but with standard. When we say customize, we're not designing boards. We're just populating these chassis with the right I/O set to their DUT. But it's more than just the hardware. I mean, there is an aspect of engineering a test system that is the software from host side software to FPGA IP,
right.
that being able to standardize on a platform, there's this human cost of engineering time, and engineers want to work on interesting things and be able to write interesting software, and being able, I feel like there's having that kind of deep control of your test system is is more engaging for an engineer. I know whenever I was an engineer, it's like, hey, I was more interested in writing something that I could get down into the guts and then reuse that. And so there's this reusability of the software. So if I design it for this module, I can reuse that in the future. Makes life less stressful for me because I'm familiar with this hardware. I'm not having to relearn a new software platform each time. And so it's like that individual can have more productivity in what they're delivering to their organization, and hopefully get promotions and pay raises because they're delivering something that's effective for the task at hand, and so being able to manage that software in a modular way, I think is a nice benefit of, of modular hardware, I guess.
Yeah, can I?
Absolutely.
Yeah, maybe pull me out of that hole there. It was some leaps in there, right?
Rabbit hole.
No,
it's cool.
It's true. But the point about reuse is a big thing. A software reuse has been around for a long, long time in the software development world. But in the test world, it's pretty interesting when you talk about that, because it's not just software modules, it's the actual stack, right? Like, I think you kind of addressed that a little bit. You have FPGA on a low-level hardware layer, but you might have a host application that needs to be addressed by the operators, right? And there's stacks of different types of software in there. Those things are modular too. And so if you're going to be developing a test system for a product, and you want a common user interface for the operators, you might run a test executive that uses different test steps.
Right.
But those test steps can be plugged into a modular test executive,
right,
and reused in the next test application.
Yeah, a lot of that comes down to like software abstraction layers. Like same account, but different site. There was some of the more advanced like test executives, like you were saying, they really put a lot into that modularity of abstraction. So because to that operator, they don't care. They don't want to know all those details. They just want to hit.
But it's interesting. It's almost like a matrix. You got hardware on one side and the software on the other. I mean, you can modularize your FPGA software. You can modularize your test steps. So my point being is that there's modularity in stacks as well.
That's right.
And across hardware.
I mean, I will say though, to be the I do work for NI, so don't fire me. But I mean, being the devil's advocate though, I have seen modularity to the extreme. There is a right granularity for this.
Interesting. Okay.
In that if you make things too small, then it's like I hand you a bucket of Legos. I have kids, as you can tell.
Right.
Versus larger subsystems, and so it's really matching that right level of granularity of modularity is important, and therein lies the engineering challenge, right? It's like, hey, we got this advanced thing. If you need a modular system, that there is no turnkey tester out there for it. Well, you're probably working in a market space that you're building something state of the art, and
right,
and you're not in a competitive environment.
That's right.
And so you have to customize your test solution. So that's probably a strong indicator you're working on something interesting, but building the test system in and of itself is an engineering challenge, and getting that optimized and right.
Where do you guys see modularity applied in your hardware?
In totality, we only work in the hardware interconnect, portion, or the mechanical interconnect portion, right? And so, the majority of the time is modularity comes into play when you have multiple DUTs, right, with high I/O, and so a lot of times our customers come to us because they do want that common core tester.
Yes.
Right, and so they need, specifically when we're talking about PXI, they need a floor space, right, and they don't want to take up too much real estate, or they're looking at, like I was saying before, total cost of test. They don't want to. They almost want to produce 1 or 2 or 3 core testers and replace, the 20 or 30 that they had before.
Whenever I've actually seen some testers, a customer that was looking at that, and that actually comes down to some aspects of redundancy and mission readiness, right?
Yeah.
Like if I can have 3 tests, I have 10 DUTs and 3 testers, now I can duplicate those. Well, if my radar tester or my EOIR tester goes down, shut down the squadron, right?
Right.
And whereas if I have same tester that can test both things.
That's right.
If I'm on an operational mission, maybe a tester that's on a aircraft carrier or something,
that's right.
I now have increased my mission readiness by going to a modular platform in order to
yeah, that's absolutely correct.
Yeah, I was thinking about it because I was in the Navy,
right?
And unfortunately, I never deployed to an aircraft carrier.
land-based Navy guy.
Land-based.
Yeah. Just
never got
to
your
the
sea
Navy,
legs.
One of my most proud things. I love the U.S. Navy, but yeah, whenever I was in technician school, I was an aviation electronics tech, and we would look at these. I was the IFF test guy, and I worked with these testers, and it was this huge box for testing all the IFS test sets. If that thing, and one of the reasons I never went on a ship because I was the only guy who knew how to fix that for Weapons Test Squadron China Lake, and if that one tester went down and we needed an IFF fix, that thing needed to be repaired, and so it was like, that lack of redundancy, kept me off of a ship, but I still think that impacted the risk and mission readiness of that squadron I was with.
Yeah. While that's not quite necessarily your commercial business motivation, it definitely is a key part of the whole modularity side of it, being able to reuse.
Yeah.
Most businesses, well, I shouldn't even say that. Depends on whether it's a high mix environment.
That's right.
They may actually follow exactly what you just said and try and keep the equipment available 100% uptime just for that reason, and having modularity in place there. If something goes down, maybe they only have to replace a PXI card, or maybe it's a connector or something like that. But
yeah, cost in business. To me, I was just kind of thinking. I was like, cost and all the business related things are super important, but there are these other reasons like mission readiness.
Mission readiness, right? And so you have imagine just for a second that you have a PXI card that you need to replace, right? The PXI card burnt up or whatever, power supply goes bad and goes into the system, burns up.
Never happens.
Yeah, never.
Not with the NI stuff.
Yeah. And so imagine that happens, and imagine that on the interface you have just a bunch of cables, right, that you have to remove in order to get into the chassis to replace that PXI.
So you're
card,
saying the actual physical modularity of having a Mac panel ITA in the front of that thing,
right?
You can just take
versus
it off.
versus cabling,
versus hard cabling, right?
Yeah. And so that's where you had asked a little earlier where we're seeing it benefit customers. That's where we're seeing it benefit customers. It sounds to me like modularity or the benefits of that kind of mean almost the same thing, but various different things to each one of us, being from different points of the test system. But together, all three of us can kind of bring it as a total solution, right? You mentioned FPGAs a little earlier. I know that there was a solution that we helped you guys with, or you helped us with,
that's right,
for a customer. Can you?
Actually, all of us were involved in that. Yeah.
I think we all help each other. It's kind of the reason that you brought all three of us together in studio today. It's like NI is not. We're not. We love instrumentation. We've reorganized the company into these business units where we're building more. Industry application focused solutions, but that doesn't mean we're building the whole enchilada,
thing,
so to speak. That wouldn't be of a good service to the engineers that are developing these systems, because like I said, all these systems. The wonderful thing is there's a lot of commonality and best practices and standardization, but that's a critical part of this is partnering with the right pieces of the pie to bring those expertise. We don't have the same expertise you guys do.
That's right. And we don't have yours either.
Yeah. Well, and I saw.
That's how it works.
We went on that tour of the factory yesterday at Mac Panel, and it was clear y'all have some really amazing mechanical, manufacturing capability there. And I was just going, wow, yeah, these guys know what they're doing in here in terms of these, building these systems out. It was pretty impressive. But.
Thank you.
Yeah, it was super impressive. I love seeing the manufacturing floor. It was part of the reason I got involved at Viewpoint Systems doing manufacturing tests, because I love watching machines. You guys had a lot of them. But it was also cool that you're almost have everything
vertically
on
integrated.
The one floor.
Yeah.
Not so much outsourcing, but to get back to your point of that particular application that we worked on together, that was specifically for, I guess I can say it, Raytheon.
Okay.
A situation where we were needing to take NI's hardware and bring in some signals from their DUT, and they wanted to be able to connect up through an ITA, but there was some signal conditioning that had to happen in order to be able to bring it into the NI products. And so Viewpoint Systems has a capability of putting custom circuitry on your boards to make again, it's a modular solution, but it's customized.
Customized,
right. The last 10% that's always different. And they had some special needs, so we worked together on that and delivered a solution around that.
Interesting. Hayden, last night you were talking about, we went out to eat last night, and you mentioned that you were a gamer. What was your handle?
Oh man, I can't put that on the news wires. There, people will.
No, come on, tell us your handle.
Trade secret.
Hold on, tell us your handle, and then tell us what game you're playing, so that we can go whip up on you.
Yeah. Well, as I've I don't have as much time to game anymore. I used to years ago, and
such a Generation Xer.
Yeah, I know. Dr. Insane was the name. Oh man.
You say Dr. Dre? What'd you say?
I actually, despite what you may think, I do not have a PhD.
Wow, now you're just blowing your cover.
Yeah. Dr. Insane.
Yeah. So I used to play play a lot of a lot of online games. The back in the day, and it was I think one of the things we had spoken about was kind of some of the aspects of that was I always preferred the type of online games with people that where I could work with other people. Like, you can play these games and it's a grind and whatnot, but I always prefer the ones that you had the ability to meet people, the social aspect of it, that I could work with a squad or fly a helicopter and and the teamwork aspect.
Oh, there's
a
team. Yeah, you guys formed a team.
Right,
yeah, awesome.
And just be able to find people that would good communication, good good cooperation, and I always I guess the ex-military side of me enjoyed those aspects of it.
Oh, not just ex-military. I mean, I love working with partners.
Right.
You guys.
Yeah.
Mainly because you form the relationships and you can rely on each other to get the job done.
Get the job done.
We've worked with other machine shops, for example, that we just don't work with anymore because they never formed a team.
Right.
It's really important to have good relationships with everybody because we're all going for the same goal, right?
Right.
Yeah.
To help the customer, right?
I've gone into, in that vein, I've gone into customers and I always get nervous in that I'll be like, oh, we need X, Y, Z, and there'll be aspects of the problem that I'm like, we can't do that. But having the right, teams and partners connected, I just go, I need to introduce you to Jim or to the right partner. We can bring the whole solution together, because oftentimes that requires kind of a whole group.
So yeah, Hayden, you guys are working a lot in the infrared electro-optic space. Tell us a little bit about the challenges that you're kind of seeing there.
Yeah, we're so that it's been an area of technology I've taken on at NI, to manage for the past 2 years. It's been really exciting to get to plug in with these customers, and it's been an intense, a pretty fun ride, because we're seeing a lot of adoption and growth in the space from a business standpoint, and it's really fun to get out and talk to these customers and hear. I walk through their manufacturing floors and I see a lot of the equipment and the way that they're testing the cameras. You can think of these things as like really high-end cameras. A lot of these will go on like space-based imagers. We think of we all use Google Maps, right?
Right.
And that's kind of the satellite imagery. Well, that comes from a camera in space, and that thing better work every time.
Right.
A very expensive camera that can't be repaired easily.
Yeah.
You're not going to fly anybody into space to fix this thing, right? So it's got to work properly.
So testing's a big part of that.
Right, it is.
And the same type of technology goes on aircraft or ISR missions. And I was actually, I'm a big military history nerd, in that I read a lot of these books about the famous Navy SEAL operations. And one of the most famous ones is Marcus Luttrell. Operation Red Wings was this operation where Marcus Luttrell was doing a mission, got stuck behind enemy lines. His whole squad was, unfortunately killed, except for him. He was the lone survivor. Mark Wahlberg's in this movie.
Wait, this is in Afghanistan, right?
Yeah, in Afghanistan.
Yeah, okay, this one I know.
Okay.
Yeah, they made a movie adaptation of it. And
I read the book.
Yeah, what I'm trying to connect to in the EOIR space is the only way that they were able to get in on that operation was because they were landing in, low visibility environment. It was nighttime operation. There was a lot of clouds and fog, and apparently helicopters kick up a bunch of dust, I'm told. And they were, being able to get in and get Marcus out was heavily reliant on these electro-optic and infrared imaging technology. And so to me, like, okay, we got a cool test system. I'm an engineering, nerd, and I like that kind of stuff. But I also like to connect it to those things that are like saving people's lives.
Right.
And that particular one, I was actually at a trade show, and I was sitting at the Raytheon booth, and they had a bunch of camera systems sitting there, in their booth, and I was just nerding out on all of it. And a gentleman was standing there, and I go, hey, I was explaining the Operation Red Ring story. And he comes to me and says, and I'm explaining it to him, and he kind of gets offended at me.
Wow.
This guy, and he was like, did they put you up to this? And he starts pointing to his colleagues, thinking they had kind of like asked me to walk over. And I was like, oh my God, I've pissed off this guy. I have no idea. It turns out he was the pilot who flew that mission to rescue
That's
Marcus
awesome.
Luttrell.
That's
and
cool.
I was just sitting there going, yeah. And then I again start nerding out on all the infrared technology in the booth. But to me, that was the kind of the neat thing about just understanding the kind of the end goal of like it's more than military operations. Being able to survey weather patterns for climate change and
a lot of commercial applications.
Right.
Absolutely. Yeah. Oh, that's a cool story though.
Yeah, it was kind of a cool one. But I mean, I guess the trends in the test space, that's why I work pretty closely with Jim at Viewpoint is about 80% of the architecture of these systems is identical. But it is, again, that last 20%, and it's being able to, it's kind of like they're all like a little snowflake. They're all a little different, but pretty similar. And you got focal plane arrays with readout ICs, and they're going through a technological shift right now where it's higher resolution, higher frame rate type of imagers, and that's resulting in the need for all this digital test.
Huge amounts of data, yeah.
What have you guys seen in that space?
So yeah, it's interesting. So we got involved in this probably 10 years ago, and it was very much almost like what we've been talking about with the modularity side. The initial system was very custom. We were able to use NI's, FPGA's, FlexRio cards in that, but there's a lot of custom stuff that went into it. And over the last 10 years, people have gotten more standardized, like you're saying, being able to use traditional types of LVDS communication, CML. But there's a hardware layer that's becoming more common. And then there's communications protocols that are sitting on top of that. They're becoming more common. And we've been able to develop a platform that fits that 80, 90% done called ADAS with that last 20 to 10% to tweak it for what the customer needs because things are becoming more common. And it's pretty interesting. The thing that's driving most of it is the fact that people want to be doing more and more data, more frame rates off of those things, higher frame rates, higher bit depth, more pixels, and pulling off data at gigabits per second now. It's just amazing.
I mean, oftentimes these things are high-end cameras, and you think of a $1 million camera, right? I better test that thing.
Oh gosh, at least $1 million.
Yeah, that's the cheap one, right?
Yeah.
And being able to test that thing really well, and noise is an esse. Any kind of electronic circuit that apparently noise comes from thermal energy. Who knew? Physics is real. I've learned. Yeah. To popular belief, but yeah, physics is real, and so that's the most impactful thing I'll say today. These things have really low noise, so if you want to get real hot, you imagine taking a picture from space. You better have pretty high resolution, which means you better have pretty low noise on your detector. And so testing these things under real flight-like conditions is becoming more and more important, and that comes down to being able to have really low noise power supplies. And a lot of times, in years past, there's just these testers that I've seen out there are all customized using like Xilinx evaluation boards. Xilinx make great products, but their eval boards, they're not intended for that purpose.
Well, that's because all the engineers that are working on those products are used to those eval boards, but they don't think about, they're design guys. They don't think about test, right?
Right.
And yeah, it's pretty interesting what you just said, because it ends up that from the purpose of being able to build one of these things, you actually have to have two approaches. So ADAS does both generation of signals, so you can emulate the imager and use all the downstream electronics and see how that's going to be able to process the signals. Or you can flip it around and record data from the imager. And so there's modularity all over it again, too.
Right.
You use almost the same exact hardware for two purposes.
And that also has like this operational benefit that, you know, oftentimes the engineers building the focal plane array imager and the people building the processing system are two different teams.
Yeah.
And being
able to do that development in parallel is a huge advantage for time and space. Cost.
I was at a customer site not long ago, and they you know, were like, yeah, we're kind of stalled on the electronics piece because we're waiting for the imager folks to get their act together, and we're just kind of going like, man, that seems kind of inefficient, and so it's that y'all have to wait for these two teams to come together at the right time, and apparently, I'm also told that engineering schedules tend to be flexible sometimes.
Well, a lot of times these guys, the ones with satellites at least anyway, they have launch windows.
Right.
They have to be ready.
Yeah. Right.
There's not that many launch pads out there.
I mean, the other aspect of that, coming back to the modularity, Matt, was the, you know, all of these have different I/O connections. So matching the right solution, the right I/O panel, the right instrumentation, and it's more than just that. It's that software and that IP, and so bringing that to, you know, to the customer by one company is, you know, is really hard. It's really hard.
Right. Yeah, and so, you know, wrapping that back up into the modular, but more so into that partnership, you know, approach is that you know, testing these devices, right? It's real world applications that these things are going into, right?
Absolutely.
They're saving lives. They're predicting weather. They're finding mice in walls, right? That's something we were talking about yesterday.
Thanks for bringing that up on the public space. I think I got a mouse on my wall. Luckily, I didn't start cutting sheetrock the other day.
Like me when I lost my cat in the sheetrock.
Yeah, I have an infrared imager in my attic trying to track these mice. You know, that was my engineering solution.
But it's like, it's real world applications. You know, it's bigger than us, right? It's not like we're just putting these things together for nothing, right? I mean, we're out here saving lives, and so it's important that our testers are operational, are and high performing, right? And like you were saying, it's hard if you're a test engineer trying to do a homebrew that's going to be everything that it needs to be.
It takes too much time and too much cost.
And that engineer is going to move on. That engineer, these testers, like back to the obsolescence thing we were talking about earlier. That tester's got to live for. What's the longest tester you've ever seen, Jim?
So I can tell you.
Bad question, right?
No. So I know of one situation where Viewpoint installed a test system and have upgraded it twice over the almost 30 years we've been in business.
These things got to live a long time.
Yeah, they live about I'll say 10 to 15 years, about max lifetime.
So it's imperative.
Oh yeah, it's super imperative that they be maintainable and reliable.
Right. And we don't expect our customers to know it all. We expect them to know where to go to get that information, right? And that would be us.
Yeah, well, it's our job to make sure that they do know that.
Exactly.
Yeah.
I mean, I've seen these situations where they have a tester that's like late in a program cycle, and it's like, it's a huge risk to that program late in the program. In that, if that tester goes down, this program goes down, and now we can't fly this specific mission.
That's right.
And and if that tester breaks, it's this huge expense, unexpected expense for that program that they have to undergo.
And delay. I mean,
Yeah.
So what you asked me about how things are going with the EOIR ADAS tester. I can tell you that the first one we did 10 years ago, their schedule was probably twice as long as it is today. So when they bid on projects, they had twice as long to implement last time, but nowadays it's half the time. So they're under real pressure for schedule and budget too.
Right. Yeah.
But you need a good team, and likewise too. I'll just throw in having a customer that is part of the team is huge.
Absolutely. Yeah. You're right.
I've seen that that before, where and customers being aware of the this is what we appreciate getting here in the podcast with you today, Matt, is that people being aware of the solutions that are out there, because I've actually run into, I think you were with as well, Jim, that if they're not aware, then they'll just start engineering their their solution, and then they learn about something that's a better way, and they go, oh, I wish I would have known about this a year ago.
That's right,
Just a month ago, I had somebody say that. Where were you a year ago?
We're like, we were here, but they weren't aware. So
That's
like,
right.
and so it's kind of a, making sure people,
right.
Even if they use NI, Viewpoint, or Mac Panel or don't, but just being aware of the solutions, your options on the table, your cards in your hand that you can play to win that,
that's part of why we're doing this podcast.
That's
so
right. Yeah, to make people aware,
make people
right?
aware. But yeah, it's super important to be able to know that there's team players out there that are trying to solve your problem.
Yeah,
absolutely.
well, and a lot of times it's that I, as an engineer, when I started it, I used to work at a defense research lab, and being able to program my own FPGA and build it all myself, super valuable, but probably not the most sustainable solution long term. I mean, I remember manually testing. It was in the radar space, but radar systems, and we weren't able to test. We tested as much as we could in the lab, but it was all very manual. And automation, automation would have removed a lot of that human error. And I got this radar test system out in the field, tested it with a real radar, and we had all kinds of problems. And I'm going, oh God, I'm going to get fired. Didn't get fired, but it's still being able to test more. Modularity and automation allows you to test more earlier, so you don't get surprised when you do like an open air range test. Like, hey, so say we had this camera and now we mount it on the front of a helicopter and we go test it in desert operations, and we're like, why are we getting all this noise? Why are we getting and it would just. And then they would have to go back to the lab, figure it out. I mean, the cost and time and risk, and so being able to have modular automated test is a huge benefit to just being able to get that to to the end warfighter faster. In my mind,
absolutely, yeah. I mean, it sounds trite to say, but it's so true.
Yeah.
Well, look, guys, it looks like we're running up against our time here. But if you're like the engineers and the companies that we've spoken about in here with certain problems that you're facing, and you need a good group of folks to partner with to help you solve those issues, I'd highly suggest that you go to macpanel.com/modularity. So until next time, this has been a great episode with Hayden Nielsen with NI and Jim Campbell with Viewpoint. Thank you for joining us on this episode of Mac Panel Test Connect.